CRUD operations are extremely helpful to learn when you are just starting out a particular language. So in this video, we will cover how to create a new .NET Web API in .NET 8, and we will create, read, update, and delete resources in our database. We will use Entity Framework Core and connect to a SQL Server database using a code-first approach. So let's dive right into it. I have opened Visual Studio, and this is what we will use to create our new ASP.NET Core Web API. This is the first screen that you will get from Visual Studio, and over here on the right hand side you can click on this button to create a new project from the templates that are available to us. On the next screen you'll be getting an option to choose the templates. In the filters over here I have C# all platforms and web selected, and from the list over here we are looking to create a .NET Web API, and if you browse through this is the template that we are looking for. It reads that it is a project template for creating a RESTful web API using ASP.NET Core controllers or minimal APIs. And in this example, we are only going to use controllers and we are not going to touch minimal APIs, but this is a template that we are going to use. So we will select that and click on the next button. On this screen, we want to give a name for the project, and I will give the name as Employee Admin Portal. And that is the same as the solution name. If you wanted to have a different name, you can clearly change that. And this is the location that I'm going to store my project in here. So I will click on next. Over here, Visual Studio is asking us the framework that we want to build this project on. And if I open the drop down, it will show you the installed versions of .NET SDK and runtime that you have on your machine. So for example, I have .NET 5, 6, 7, and 8. Clearly, .NET 8 is the latest version as of now at the time of recording. And I will select that. And if you don't have this option available, you first have to update your Visual Studio or reinstall a fresh copy. After that, I will not touch any of the other settings, so I'll keep it as default and just want to focus on this point that we are using controllers, so that is checked. And after that, I will click on the create button. It takes a few seconds for Visual Studio to create this template for this project, and it'll look something like this. We have the overview page which we can close, but the main magic is happening over here on the right hand side. These are the files and folders that have been created by Visual Studio for our .NET Web API project. And if you see on the top, we have the solution file, which is kind of a structure, and it holds multiple projects together. It holds one or more projects. At the moment, we only have one project, and that is also set as default so that we can run this project and test our changes. After the solution, we have multiple projects, and this is the project that we have. If I double click on the project name, it will open me the project file, and the project file basically has the target framework, the one that we are using, which is .NET 8, and it also stores the packages that we will install later in this video in the project file over here. After that, we have the properties folder, which has the launch settings.json, and as the name suggests you that it's the launch settings, it basically holds all the profiles in which we can run our application. For example, we have the HTTP profile and we also have the HTTPS profile, and currently if you see over here, the play button has the HTTPS profile, and I can switch between HTTP, HTTPS, and IIS Express profiles, but for now I will use the HTTPS profile, and these are the application URLs that my solution will run on. So if you open your launch settings.json, your localhost port number would be completely different. The next thing we have in the solution is the controllers folder, and this is the folder in which we will add our endpoints, which are basically converted from controllers. So we will add a new controller and we will add various endpoints or operations like get, post, or delete as well inside this controller that we will create. But by default, we get an example controller, which is the weather forecast controller. Then we have the app settings.json file, and any settings related to the application, for example the connection string, can go over here. Later in this video, we will come over here and add the connection string to our SQL Server database. Then we have the program.cs file, which is the main file in our application, and this is also the entry file. So the code starts to execute from this file whenever we are deploying and hosting our application and running our API over here. So as you can see, we are building some services inside the application, and we are finally building that. After that, we have the middleware, the HTTP request pipeline, and that's in this particular order as well. This is an important file, and we are going to use this file to add some dependencies related to the DBContext, which is a entity framework term, but we are going to inject that inside the program, and we are going to later use that DBContext that we have injected over here inside the controller so that we can make a connection to the database. A new thing that we get inside the .NET 8 web APIs is this file over here, which is the HTTP file, or if we open it, it shows you that this can be used to make a request to this endpoint over here. And to make this request, I can just run the application, and I can also view this from the view toolbar, view, other windows, and endpoint explorer. Over here, we will get a list of all the controllers and the endpoints that are available inside the controller. And you can also generate this request, but we already have that. So I'll just, delete that over here. And once the application is running, so the browser is running and it's running Swagger as usual. And over here, if I send the request, we are getting the response back as 200 OK. So it's basically making a request to the weather forecast controller, and there's a randomly generated weather forecast over here as an array, and we are getting the result back over here. But we still have the option to use Swagger and execute our request from here. So there's another way added from Microsoft to basically run and test your APIs, but I'm still going to use Swagger because that's on Open API 3.0, and that's a very good way to test our application, because not only it allows you to test the application, it also shows you the schemas that are available, the post requests, the body that it needs, and the response that it's going to send back. So in our application, when we build the endpoints, we are going to use Swagger to test it. It's now time to write some code in our application so that we can build our .NET Web API for these employees and adding the details in the database. But before we do that, we have to install some packages that we would need to make a connection to the database. And these are Entity Framework Core packages. So to install the packages, which are NuGet packages, we have to come over here on dependencies, right click on dependencies, manage NuGet packages, and it'll open up a window. And in the browse section over here, we will basically browse for these two packages and install them one by one. So the first package is Microsoft.EntityFrameworkCore.SQL Server. I'll copy that and paste it in the browse section. And we are basically looking for some version of .NET 8 because we are running on .NET 8 framework. So this is the latest version, and if you're coming here after an year and maybe .NET 9 is available, just use the same framework as what you have installed. So I'll click on this package and click on install. And similarly, I will also browse and install the second package, which is the Microsoft.EntityFrameworkCore.Tools, and I'll select that and install that as well. Now that we have installed the two packages, they should end up in the project file. And if I open the project file, we can see that the first package is over here and the second package is coming over here as well. So the project file also contains the references to the packages that we have installed. The next thing that we will do is that we will create the entity that we are going to save in the database. So that will be our models and in what state we want to save our data in the database. So first of all, we will create a models folder. So right click on the project over here, and we will come to add a new folder, and I will name the folder as models. And inside the models folder, I will create another folder and call it entities. And entities are basically something with an identity. So this entity will have a primary key as identity, and this is the condition of the employee that we are going to save in the database. So in here we will create a new class. So add a new class, and we will call this class as employee. So I'll call this employee.cs. Now in this employee class we will add some properties, and these properties will signify the columns that we will have in the table that we are going to create in our SQL Server database. So the first property that we will have will be a identifier, and that will be of type GUID, which is a globally unique identifier. And the second property that we will store is the name of the employee, which will be a type of string. The third one will be the email address, another string type. The fourth one will be phone, and we will use a string again to store something like plus and spaces in between. The next one will be the salary, and this will be of type decimal. Now you can see that we are getting some warnings and some green squigglies over here that it says non-nullable property name must contain a non-null value when exiting the constructor. So basically it's asking us that this property of type string, is that a required field? And if it is, it should be exiting from the constructor as a non-nullable property. But we want to make some properties as required fields and some properties as optional. So basically there's another way, a new way to do it in C#12, which is from the required attribute. So inside the property over here, we can use the required keyword, and this will make sure that when we are about to initialize this employee object, we have to specify a value for name. Otherwise it will throw us a compilation error, and we won't be able to initialize an employee object without the name property. And if your business is requiring the same thing for the email address and the phone, that's totally fine as well. You can add the required attribute to email and phone as well. But just for the sake of this example, let's say the phone was not required. So that will make it a nullable property. That means the phone can be a string or a nullable. And in that case, we have to use a question mark to make this as a nullable property. So now we have defined our employee object. It's now time to create the DBContext class, which is also required by Entity Framework Core to make a connection between the database and the application. So to create the DBContext class, I will first create a folder for that. On the project, right click, add a new folder, and I will call it data. And inside the data folder, I will create a new class, and I will call that class the DBContext. So I'll say application DBContext.cs. This application DBContext class will basically inherit from another class, and that will be the DBContext class. So DBContext, and this class comes from the package that we installed over here, which is Microsoft.Entity Framework Core. So I'll select that, and you will see the using statement on the top over here as well. Then we will create a constructor for this class. So CTOR to create a constructor, and we will pass the parameter DBContext options. So DBContext options of type, and the type is the DBContext itself, so application DBContext. After that, we will give a name for this. So let's say options, and I'll minimize this, and we'll also pass these options to the base class. So base also pass the options over here. You can write the constructor manually as well, but there's another way to do it. If you come over here and imagine this is not there, you can click on the class, press Control dot or Control period, and you can see that Visual Studio is suggesting us to generate the constructor application DBContext with the options parameter. And if I select that, it's basically giving us the same thing along with the type of the DBContext options, which is optional for now. If we have multiple DBContext, only then we have to give the type of the DBContext over here. So for this one, anything is fine. You can write this manually, or you can generate it from the IntelliSense. The next thing that we are going to do in this DBContext class is that we will add a property for the collection that we are going to store in the database. That means we are going to store employees in the database. So we want to have a DBSet type of the employees. So I'll create a property, and the shortcut is prop, press tab to create a property. Now the property type will be a DBSet, and it takes a type, and the type is the employee class that we created. So the employee entity that we created, and then the name of this will be employees. We usually have the as a plural form of the entity that we created over here. The next thing that we are going to do is to add a connection string over here, and we add a connection string inside the app settings.json file. So after the allowed host section, I will come over here and create a section for connection strings, and it's basically an object of type JSON, and in this I will add a key value pair. I can name my connection string anything, so let's say this is the default connection, and after that I'll press colon, and inside string I will give the value of the connection string. And this can be a little different for you over here because this is what we have installed, and this is the SQL Server Developer Edition that we have installed, and this is SQL Server Management Studio that is used to view the SQL Server instance that you have installed in your system. So to check if you have the correct version installed, you can come over here inside SQL Server Management Studio. You can try connecting to the server that you have, or you should install it. So this is the connection, the server name that I have installed, and this is Windows authentication. So just to check if this is the correct server, I can connect it, and you can see that it instantly connected. And in the databases over here, I can see many databases over here. So once you know what the server is that you have installed in your local host, now you can come over here inside the connection string and define the server. So the server is equal to, and then the value of the server name, which in my case was this, and in your case it could be something different. Once you have defined the server, we'll put a semicolon and define the database. So database is something that you want to create because the database does not exist at the moment, and this is the code first approach because we have written code for the employees collection first, and now we are about to create the database for it. So this could be anything, but for this example I'm writing that this will be the employees DB. After that we have to write two things, which is the trusted connection is equal to true, and the last thing is trust server certificate is equal to true as well. So once you have defined all of these four things inside the connection string, we have done our work inside the app settings.json, and we are going to use this connection string inside the program.cs file. In the Solution Explorer, we will open program.cs file, and we have a few services that we are injecting in the builder over here, but we are going to also inject the DBContext class that we created so that we can use it inside the controller or any other class inside our application. And the way to do it is using the builder class. So the builder object dot services dot add DBContext, and this is the method that we are now getting. Add DBContext of type, and the type that we have is the application DBContext. So over here we will write application DBContext. Press control dot or control period, and we will use the employee using employee portal.data because that resides in the data portal over here. After that we are going to use the options parameter. So options dot, we have the use SQL server method, and I'm going to shift this over here in the second line so that it's more visible. So use SQL server, and use SQL server has or takes different types of parameters, and one of them is the connection string, and it's of type string, and we are going to fetch the connection string over here from the app settings that we have. And the way to do it is using the builder again. So builder dot configuration dot get connection string, and we want to get the connection string with a certain name. So if I open the app settings again, this is the name of the connection string that we have. So copy the name, and if it's different from you, you can copy the name and then paste it over here so that there's no error. And I will complete the bracket, and I will add the semicolon to end the statement. So this is the way that we are injecting our application DBContext inside the program.cs file. So now we are just one step away from creating our database, and that step is the Entity Framework Core migrations. And that is a way for the application to create some files in C# and then execute these files. And because we have given the connection as well, they will execute this C# classes and convert that to SQL to create a new database and a new table as well. So to run Entity Framework Core migrations, we will first come to Tools. We will go to NuGet Package Manager and open Package Manager console. This will open a window over here where we will write two statements, two commands. The first command that we will write is add-migration. And after that, inside the double quotes, we can give a name for the migration. Because we are creating the database for the first time, we can call it initial migration. And after that, press enter to run this command. It takes a few seconds for it to run the command, but once it has done it, it will create a new migration class. And you can also access the migration class from this folder that has been created. We have also got a new migrations folder, and we have got the initial migration class. If you open the class, we will have two methods, up and down method, and this is basically a way for Visual Studio and C# to know that what it has to create inside the SQL Server database. So it's creating a table that we have the employees table, and it knows about all the fields that we want to create in the table because we defined them inside the entities which are connected to the DBContext over here. So it creates a C# version of what it wants to execute inside the database, and the next step then becomes to execute this. So I'll come back to Package Manager console, and the next step is to run this migration, and the command to do that is update-database. Press enter and it will run the migrations that it hasn't run before, and it knows the connection. And you'll get an error like this one, and it says that only the invariant culture is supported in globalization invariant mode. And this is a new error that we now get in the .NET Core 8 or EF Core 8 actually. And the way to go ahead with this one is that over here inside the project file, we have this property that says invariant globalization as true. You just have to make it as false and save the changes. Now if we come back and run the statement again, it should now run fine, and it should now run the migration that you created and execute it in the SQL Server database. So it looks like the migration has run successfully, but there's only one way to check it, and that's by connecting to the server that you have. So I'm already connected to the server, so I just need to refresh it. And if I refresh it and open the databases, I now have a new employees DB, which should have one table, and that is the employees table. And it is over there, which has the exact number of columns and the exact type of columns that we have defined in the entity that we created. So now that we have created the database from the application, it's now time to create a new controller and the CRUD operations in this new controller. So I will come over here in the controllers folder. I will right click on that and add a new controller. From the options over here, I will select the API option, and over here I will select API controller empty and click on the add button. Then we want to give a meaningful name to the controller, and every controller name ends with a suffix of controller so that Visual Studio knows what's a controller and it treats it as an endpoint. And the controller that we are about to create is the employees controller, because we are going to make different actions on the employee. So we are going to name it as employees controller. Now this is the class that we get from generating the controller file, and in this class it's inheriting from the controller base class, and it also has the API controller attribute and also the route attribute, which says that it is going to be accessed from this particular route over here. And if I put a comment over here, it's basically going to the localhost port number that your application is running on. After that, there will be a /API/ the name of the controller, and the name of the controller is employees controller, but by using this kind of a convention, it automatically maps the name of the controller over here. So the route for this one will be employees. Now inside the controller, we are going to add the endpoints or the operations, which are the CRUD operations, and we can start by a simple one, which is reading all the employees from the employees table. And to do that, we are going to create a HTTP GET method, which is denoted by this attribute HTTP GET. After that, we are going to define the name of the action method. So public iAction result. Then comes the name of the method, which could be get all employees. After that, we will open and close brackets. So this is the structure for our method, and it needs a return type of iAction result. Now this method can basically return you a static list of employees, or it can actually connect to the database from using the DBContext file and get you the live result back. And that is the option that we are basically wanting to have in this video. So we will need to connect to the database using the DBContext. And if you remember, we injected the DBContext in the program.cs file so that we can access it anywhere inside the application, even in the controller. So the way to inject that inside the controller is through constructor injection. So we will first create a constructor, CTOR, press tab to create a constructor, and we will inject the application DBContext over here. So application DBContext, give it a name, let's say DBContext. Press control dot or control period over here after you have clicked on this name, and from here you can create and assign a private field, and this is the private field that we will use inside the different methods. So now that we have a field over here, we can use it inside the get method over here. So inside the get method, I will say DBContext dot, and once you press dot, it will have all the properties available to you that we have defined in the DBContext. And one of the property was the employees property, and you can basically treat this as the employees table. So DBContext dot employees dot, and we want to get all the results back. So we can say dot to list. And once you have the dot to list, we have basically the result. You can put it in a variable, let's say all employees, and if I hover over it, you can see it's a list of the employee entities, and you can return this back because we are using the APIs and it follows RESTful conventions. We want to send this as a OK response, so we'll say return an OK response, which is creating a 200 success response behind the scene, and we will pass the employees object as a result of that. And you can see how simple it is. It's only these two lines of code. We are connecting to the database, and then we are returning the list of employees back. It's now time to test the application. So I've run the application again, and I've opened the browser. Inside the browser, I can see a different controller, which is the employees controller, and it has the various endpoints available for us. And the first one is the get operation. So I'll expand that, click on try it out, and click on execute. It's now trying to make a connection to the database and fetching all the result back. So as you can see, we have the server response over here, and the server gave us the 200 success response. So basically the request was successful, but the result was empty. And that is true because we don't have any employees in the database at the moment. What we can do is we can come over here and add an employee manually just to test this function. So I will come over here, edit top 200 rows. I want to now give the values of these fields, starting with the identifier. So I will come online and find a GUID generator. I will copy that and paste it in the ID. Then I can give a name. Let's give it my name or your name, and some email. So this is a very genuine email. And after that, we can specify a phone number, and then maybe some salary as well. And once you tab it, the row will be saved, and if I want to select it again, we can select this, and you can see now we have one entry in this table. And now if we come back to Swagger to test our endpoint, we can execute this again, but this time we get the result from the database back. So you can see that we got the ID back, name, email, phone, and salary from this database. So you can see how easy it is to create this endpoint, which is the get endpoint that we have. And it's basically one line of code. We have just extracted that into 2 lines by creating this variable, but you can do this thing. You can just copy it over here, and that becomes your 1 line of code. And this is all it is for the get operation that we have. The next operation that we want to build is the functionality to add a new employee from the application. And for that, we want to create a new action method over here in this controller. Apologies for stopping the video in between, but I have created this comprehensive course on .NET Web APIs that covers building web APIs from scratch to finish. Along with CRUD operations, you will get best practices, different patterns, clean coding techniques, authentication and authorization, and so much more. This is the top performing course on .NET Web APIs on Udemy, and I'm sure you will love the course as thousands of other students have. For my YouTube audience, I have this course on sale, and you can avail the discount by clicking on the link in the description. Let's now come back to the video. Let's create this structure for the action method for adding a new employee, and that will be the post method because that is as per the RESTful operations. So we use the HTTP verb of post. So HTTP post is what we use for the add operation, and we'll define the structure of this action method. So public I action result, and we can call this add employee. We will define the method structure. Now to add an employee, we need a few details of the employee. If we come back to the models folder, we have the employee class, and apart from the ID, we need the name, email, phone, and salary. And from these 4 properties, we know that the name, email, and salary are required, and phone is an optional field. So it's, if the user wants to give it, they can, and it's basically optional. So we want to accept the parameters as the body of this post request. That's the HTTP body, and we want to create a new object for this one, which will be as a carrier of this data. And for these type of objects, we use DTOs, which are data transfer objects. And as the name suggests, they basically transfer the data from one operation to another. And for this one, we will create a DTO inside the models folder. So over here, right click on the models folder, add a class, and I will name this class as add employee DTO.cs. And this add employee DTO.cs class will have similar properties to the entities class because we want to accept the name, email, phone, and salary. So what I can do is I can copy these 4 properties and paste it inside here. So these are the properties that I want to accept from the user. Now I can use this object inside the controller as a parameter. So inside the add employee method, I will define the parameter type as add employee DTO, give it a name, let's say add employee DTO. The first thing that we will do over here is that we will map this add employee DTO, and we will convert this into the entity that we have, because the DBContext class that we are going to use to add this employee only accept the entities over here. So to tell you what I mean, we want to ultimately save this employee in the database, and we do that using the DBContext file, and we have injected that over here. So we'll say DBContext dot employees table, if you want to call it that, dot, we have the add method available to us, dot add, and if I open the bracket, you can see that the add method on this employees table accepts this type of file, which is the entities employee. So this method needs the employees entity type, but we have available with us the employees DTO. So we have to somehow convert this from the employee DTO to the employee entity. To do that, I will create a variable over here. Let's say employee entity is equal to new employee, and this comes from the employee entity over here. So press control dot, and we have the import statement of entities, the folder. After that, if I press enter, we have the properties available to us, and you can see that the required properties are also there, the ones that the class needs for us to fill. So we won't fill the ID because Entity Framework Core handles the ID for us. So first of all, name, and that comes from this this parameter that we have. Then we have the email, which is also a required field, and it also comes from the add employee DTO dot email property. Then we have the phone is equal to add employee DTO dot phone, and finally we have the salary also coming from that object. Now, a lot of people think that this is just a wastage of code, and why are we even accepting, a different type of object, then converting it into the entity and passing the entity. And the reason for that is entities are separate from the DTOs, and by adding DTOs we achieve a separation of concern. We are basically exposing this information to the outside world, this DTO class, whereas the employee entity is as an image of what we have in the table or the database. And you can have different names. So instead of name, we could have had full name, and to the outside user we could only expose name, or let's say separate fields as first name and last name. So it gives us a lot of modularity, and by achieving this type of separation between DTOs and entities, we make our code quite reusable and generic and readable as well. So now that we have converted our add employee DTO into a employee entity, we can now use this employee entity and pass it to the add method over here. Now I'll put a semicolon to end the statement. By this line, it won't do anything at the moment. So if you think that by doing this line we'll be able to add the employee to the database, that is incorrect, because Entity Framework Core wants you to add or save the changes yourself. So it wants you to save the changes. So by using the DBContext class again, we have access to a method called save changes, and only when save changes is called, the actions that you want to do is then transferred to the database, and finally this employee would be added to the table. Now this needs a return type, as we are returning a action result to tell the client that the operation was a successful operation or not. So as a return type, we will say OK, which is a 200 success response. Ideally, in an HTTP post response, when we are trying to add a resource, we want to send a 201, which is a created response. But for this example, we'll just use the OK response to simplify things. And in the return type as the object, we are passing the newly created entity. And this entity, when this is returned back, you can see that the ID is not being initialized at the moment, because Entity Framework Core will handle that for us. But when this is returned to the user, it will have the ID as well. So I'll run the application, and I have Swagger over here, which now shows two action methods. One is the get operation, one is the post operation. The post operation, as you can see, is pointing to the same route as the controller, and also the get method, because these are following RESTful practices. Now I'll click on try it out, and we get a request body. And request body is the DTO that we created. So the action method needs this information for it to add this employee. So I'll add some details over here. So I've added some information over here, and I'll click on execute. And this is now connecting to the database and trying to add this new employee. It comes up with a success response, so that is good news. We get a 200 success response, and the response body is giving us the newly created employee. This is the information that we passed to the method, but it also created this unique identifier and gave us the response back. If I now go to get all the employees and try to use that method, it will have two results, the one that we created manually and the one that was created by this application. All right, moving on to the next operation. Sometimes in our application, we want to fetch a single result. That means a single employee by its unique identifier, that is the ID. And we currently have all the employees coming back, but this is a result set that is having some extra information of other employees, which we don't want. We only want a single employee information. So how can we achieve that? For that, that's another get operation. So we will first have the HTTP get attribute. After that, let's define the method. So public iActionResult, and we will change the name of the method to get employee by ID. Now, because we are trying to get an employee by a single ID, this method needs to know about the ID that it wants to search on the database. So as a route parameter, we will accept a identifier inside curly braces over here. I'll say ID, and we know that the type of this ID is a GUID, and this is trying to make things more type safe. So I'm accepting a identifier in the route itself, and now I will map this identifier as a parameter to this method. So over here, I will create a parameter which is of type GUID, and the name of this parameter is ID. If you give any other name and we have ID in the route, it won't match, and the controller won't be able to map this value that is coming in the route and to this parameter over here. So make sure the name of what you are giving in the route matches the name in the parameter as well. So once we have the ID, we are now ready to call DBContext and try to fetch this employee from its ID. So we will use DBContext over here. So DBContext dot employees collection dot, and we have different ways to get this employee, and the fastest way would be to use the find operation, and find takes the primary key, and because we are using the ID, which is the primary key as well, we can pass the ID to the find method. Now we will store the result of this operation inside a variable, and we will call that employee. If I hover over employee, you can see that the type of employee is an employee or a null. So basically it's a nullable employee. The result can be an employee itself that it was able to find in the database, or if it wasn't able to find that in the database using this ID, then it will return a null value. Now we can use this employee and check if the employee is null, then we will return a not found result back. So I can return a 404, that means a not found result. And you can also pass a message, but I'll just keep it empty. And otherwise, if we were able to find this employee, and we can return the OK response back, that means a success, similar to how we were returning all the employees back. And you can see how easy it becomes once you know how to use the DBContext. We can make a connection to the database directly using DBContext, and we can search on the collection or the table inside the database, and we can return anything we want. So we have this get a single employee by ID operation, and now we can test it. So running the application again, we now have 3 operations, and the third one is getting a single employee back. And if you see the route over here, this is again following RESTful practices. The employee for the route for this operation is having the /ID as well. And this is the ID that is getting mapped from the route to the parameter of this method. Now, if I want to test it out, I want a unique identifier, which is a type of GUID, and I can search one of the ones that we have in the database. We have 2 results. I can use any of them. So Control C, Control V, and if I click on execute, you can see that we get a 200 success response, and that is the same employee for which I have given the identifier. And to confirm that, we can use the first identifier and paste that over here, execute, and we get the results for the employee called John. So till now we have completed 3 operations inside the CRUD operations, which is create and retrieve. And now we are left with 2 operations, which is the update and delete. So let's first do the update operation. And for update, we follow the convention of HTTP put. So we use the put verb inside the RESTful resource or RESTful practices when we want to update a particular resource. So we will use HTTP put, and after that we will define the name, the structure of the method. So public iAction result update employee. Now this method will also need to the information of the employee that you're updating. Now, similar to how we were doing things in the get method, because we were getting a employee based on the ID, we also want to use similar structure for the employee or for the update method. So the update method would also have a route similar to the get employee by ID method. That means we need an identifier for the employee that we are trying to update, and we also need a parameter which we can map to. So we'll have the first parameter as identifier of type GUID. The second parameter for this method is the things that we want to update. So we basically want an object like this one, and that will have the information that we want to update in this employee. So we can create another DTO. So right click on models, add a new class, and let's call this class the update employee DTO.cs. And this will have a similar structure to the add employee DTO. So if we want to update name, email, and phone, we can do that. If we also want to update the salary, we can also copy that as well. So this employee DTO will have all the properties inside the employee collection that we want to update. Now we will use this update employee DTO inside the update employee method as a second parameter. So employee update employee DTO, we can give it a name, and this is what we have over here. We have 2 parameters to this method. The first thing we will do is we will first try to find this employee. So similar to how we did this stuff in the get employee method, we will create a variable called employee is equal to, and we will try to search this employee by ID. So DBContext dot employees collection dot find method, pass the ID to it. Now this could be an employee if it was found, or it could be null. So first of all we will say if employee is null, that means it was not found, return a not found back. So return the not found method, and if it was found, we want to update it. So basically we want to say employee dot name is equal to, use this information that we are getting from the client and use this name property. So we want to change this name to the value that we are getting from this DTO. Similarly, we will also do it for email, and we will have the email from the DTO. Similarly for phone and salary as well. If you have more number of properties, you can also update those properties over here. Now that we have updated these properties, the last thing we want to do is to save changes. So if you forget to save changes, you will not see the results in this in the database. So first of all, we'll call dbcontext.savechanges method, and this method will make sure that any updates that you have over here is also shown or reflected in the database. And finally, we can return an OK response, and we can return this updated employee back. So this is the the update method in CRUD, and we are using the put verb. So it's now time to test this. We get this new operation over here, which is the update operation represented by the keyword, the verb put. And I want to try it out, and it also needs an identifier of the employee that we want to update. You can come back to the database, and let's say we want to update this particular employee. So pass the identifier and also pass this information that you want to change it to. So for example, we have the employee as John Doe, and we want to change this information. So let's say this is the information I want to change it to. I've made changes to all the properties, and if I click on execute, this should return us a 200 success response. And when it does, this would mean that our information has been changed in the database. To confirm that, we can come over here and select this again, or execute this again. The information for John Doe has now been changed to Jacob Smith, and you can see the changes reflected on the name, email, phone, and salary as well. So you can see that our update operation is also working as expected. The final operation, or the final action method that we want to add, is the delete method to delete a resource by its identifier. And we use the HTTP delete attribute that refers to the delete verb in terms of RESTful practices. And we will create a structure, and it's suggesting me this structure, which is correct. Delete an employee, it will take an identifier, but it wants to take the identifier from the route if we follow REST. So I will follow the same route over here as well. So make sure the identifier matches the parameter, and that is all the information we want to have for this delete operation. To delete a particular employee, the only thing we need is the unique identifier, and we will search the employee in the database first. If we are able to find it, we will delete it. Otherwise, we'll send a not found back. So again, we'll say variable employee is equal to DBContext dot employees collection dot find method, and pass the identifier. After that, we'll say if employee is null, then we want to return a not found back, and otherwise we want to delete this employee from the database. So we will say dbcontext dot employees collection, and we have a remove method. We don't have a delete method, but we have the remove method, which takes the entity. If I hover over it, it takes the employee entity, and this is the employee entity that we got. So we will pass it to the remove method, and don't forget to save changes. So dbcontext dot save changes. So in any other operation except from the get method, you have to remember to save the changes so that it reflects the changes inside the database as well. And after saving the changes, you can return the OK response. If you want to pass any information inside, you can pass that, but like I'm sending an OK response with an empty object back. Time to test this. We have the delete method now available to us. We'll try it out. We will pass it the identifier of an employee that we want to delete. I'll select this and pass it. If I execute it, I get the success response back. I don't get a response back because I'm not expecting that. But if I now come back to SQL Server and execute the statement again, I only have one employee left. So you can see we have finished the CRUD operations in .NET 8 Web API, and it was a very easy solution. And there's much more to web APIs, and you can find all of that in my course that has been linked in the description. And if you like this course or this video, please give it a thumbs up, subscribe to the channel, because that means a lot, so that this video and the channel can reach more users or more students like yourself. That's it for this one. Thank you for watching, and I'll see you in the next one.